This week's flexible lesson, we're going to be looking at how to solve maximum and minimum problems. So how do we take a worded problem like this one here and use calculus to determine an answer to it? So this first question here says, farmer wants to make a rectangular paddock with an area of 4,000 square metres. Fencing costs are high and she wants to make the paddock to have a minimum perimeter. Find the dimensions of the rectangle that will give the minimum perimeter correct to 1 decimal place. So the first thing to do in all of these problems is to identify what is it we're trying to determine. And in this particular case, we're trying to find a minimum perimeter. So that tells us that what we want to do is we want to develop a function. Okay, in this particular case, we might call it P for perimeter. That's a function of x, some distance, that will somehow tell us the perimeter of the paddock based on a particular value x. Once we've got that, we need to minimize that, and we can do that using calculus. So we are going to be finding this P of x. The next thing I would always encourage you to do is to draw a little diagram. So in this particular case, we have a rectangular paddock. So I'm going to draw a sketch of a rectangular paddock. And we're told that it has an area of 4,000 meters. Sorry, 4,000 square meters. And that's all we know about this paddock. And we're asked to find the dimensions of the rectangle that would give the minimum perimeter. Okay. So in other words, we want to minimize the total distance around the edge of this rectangle. Now, with all of these problems, in order to get out our P of x function, our function for the perimeter, we're going to have to introduce some parameters. So what we're going to do is we're going to call, to start off, I'm going to do this, I'm going to call the length of the rectangle x, and I'm going to call the height of the rectangle y. And it's a good idea when you're dealing with a geometric problem like this to start writing down the things we know about rectangles. So in a rectangle, there's something about area and there's something about perimeter. So let's just write down the equations that we know about rectangles. So I know that the area of a rectangle, actually I shouldn't make it a of x, I'll just call it a. Area is x times y, the base times the height. And I know my perimeter of a rectangle, well, it's going to be adding up all the sides. So 2 of the sides are going to be x, 2 of the sides are going to be y. So it's x plus y plus y, which is 2x plus 2y. That's my equation for the perimeter. Now remember, I'm trying to determine a function for perimeter in terms of x. And if you have a look at the equation I've got for perimeter here, it does have an x in it, okay? But it also has a y, and we need to get rid of the y in that perimeter equation. And we're going to do that using the information we have about the area. So the objective is to get this P equation without a y in it. And to do that, I'm going to use the area equation. So I know that the area is xy, but we're also given information about the area in the question. We're told that this thing has to equal 4,000. So this is an equation with x and y and a 4,000 in it, but it relates x and y. This is just like simultaneous equations. What we can do is we can rearrange this to make y the subject, and we can use this equation to replace the y in here. So let's do that. Making y the subject, I get 4,000 divided by x. And now I can substitute this into my perimeter equation. So my perimeter becomes this. P of x equals this thing here. And this is now my function for the perimeter of this paddock, purely in terms of x. The question though asks us to find the minimum perimeter. And to do that, we are going to need to differentiate. So this is my perimeter function. P of x equals 2x plus 8,000 on x. I need to differentiate. Before I can do that, I should rewrite this as x to the minus 1. So now when I work out p dash of x, I get 2 plus, bring the power down the front, negative 1 times 8,000 x to the minus 2. I'm going to get 2 minus 8,000 x to the minus 2. Now, turning points. Turning points occur when my derivative p dash of x is equal to 0. So I need to set this thing equal to 0. Let's tidy this up. Remember that x to the minus 2 is the same as over x squared, so I can rewrite this like that. Rearranging that equation, I would get this, that 2x squared equals 8,000, x squared equals 4,000. So x is going to be plus or minus the square root of 4,000. Now to evaluate that, 4,000 I happen to know is the square root of 400 times the square root of 10. The square root of 400, 400 is a nice square number, it is 20. So I get plus or minus 20 root 10. Now we only want the positive case, and that's because, remember, x represents the length of a rectangle, and we can't have a negative length for that. So we are just going to take the positive result, 20 root 10, and if you're interested in what that number is, we can work it out. That's about 63.25 square meters. I believe the question asked for this to 1 decimal place. It was actually 2.4 something, so 63.2 square meters is the answer there. It wants the full dimensions of the rectangle. So the question now is, that's how long this base side is. How long do I have to make y? Well, we know that the area has to be 4,000, so I can just use the area formula, that xy had to be 4,000, and then determine what y has to be from that. So we've got 63.2y equals 4,000. So y, the other dimension, has to be 4,000 divided by 63.2, which again I can't do in my head. 4,000 divided by 63.2. And look at that. Y is the same number. Well, or close to it. 63.3. Oh, and I've just realised I've put square meters in there and it should have been regular meters. So we should probably conclude this. Therefore, it's a paddock, isn't it? Paddock has dimensions 63.2 by 63.3 meters.